My name is Karen Daly and I teach mathematics at DKIT, a third level college in Ireland. This video was produced to further assist my first year computing students with their mathematical studies. At the end of this tutorial, you should have gained an understanding of how to combine transformations, thus creating a combo matrix. Enjoy! Beneath this video you will find a link to a PDF file which contains the questions that I answer in this video. I think it would be a help to you if you can to print out this file so you have the question in front of you as you work your way through the video. Enjoy again. Okay, let's look at this question. It says that the triangle R has vertices A, which is the coordinate, has coordinates 2, 3, B, which has coordinates 4, 3, and C, which has coordinates 3, 6. So they're the three corners of the triangle, the vertices. It says find the image of R when it is rotated anti-clockwise by 90 degrees about the point 3, 4. In the last video, I introduced to you a transformation matrix that does rotations. And it looks like this. R theta is equal to cosine of theta minus the sine of theta, sine theta, cosine theta, and then we've got a 0, 0, 1, 0, 0. So that was the matrix we were using in the last video. Now recall that this matrix is an anti-clockwise rotation, right? And about the origin. So about the origin, which is 0, 0. Okay. Now this matrix only works for a rotation about 0, 0. And in our question, we're asked to rotate the triangle about a point 3, 4. So how do we overcome this difficulty? Let me first create a visual of the problem by drawing the triangle in our Cartesian plane. Here you've got X and here you've got Y. Now the coordinates are 2, 3 and 4, 3. So we need to go up to 1, 2, 3, 4. So 1, 2, 3, 4. And on the Y we need to go to 6. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Okay, now if I change colours and I plot my triangle in green, first point is 2, 3, so 2, 3 is here. The next point is 4, 3, so 4, 3 is here. So that's my A and that's my B. And I want to put in my C point then, 3, 6 is here. So that's my C. So if I join all three vertices, I get my triangle, and that's my triangle R. Now let me change colours and put in the point I want to rotate the triangle about. It's 3, 4, so it's about there. Let me just put in the coordinates 3, 4. That's the point that I want to do the rotation about. So my problem is that this matrix, R theta, only works for rotation about 0, 0. So to overcome this problem, what I'm going to do is I'm going to move 3, 0 to 0, 0. This is the point 0, 0 here. And to move it, I'm going to use a translation. So I'm going to write this here. It's a translation. Right. Now, the translation, what does it do? Well, it moves from 3 to 0. So for my X, I'm going to have to subtract 3. And for my Y, it goes from 4 to 0. So I'm going to have to subtract 4. Now, if you recall, again from the last video, we had a matrix that defined a translation. It was T, A, B is equal to. It was 1, 0, 0, 0, 1, 0, and then you had A, B, 1 here, where A was my movement in the X direction and B was how much I moved in the Y direction. So for my particular application, the transformation matrix is going to go 1, 0, 0, 0, 1, 0. The A value is going to be a -3, and the b value is going to be a -4, and that's going to be a 1. Now that translation matrix there is going to move my point 3, 4 to 0, 0. And what I'm going to do is I'm going to apply that translation matrix to my 3 vertices for R and move R also. Once I have moved 3, 4 to 0, 0, using this translation matrix, what I can now do is I can now use my rotation matrix to do the rotation. So let's look at the rotation. Right. So I firstly do the translation, then I'm going to do the rotation. So the rotation is, theta is 90 degrees. If you work out the cosine of 90, you'll get 0. If you work out the sine of 90, you get 1. So what you get is the rotation matrix is 0, -1, 0, 1, 0, 0, 0, 0, 1. So that's my rotation of 90 degrees anti-clockwise about the origin. Now once I've done the rotation, then what I'm going to do, the third step, so let me write that in green, third step. The third step is I'm going to move everything back to its original position once I've done the rotation. So what I do is, again, I move back from 0, 0 back to the point I was originally rotating around, which was 3, 4. So that's a translation. I add 3 in the x direction and I add 4 in the y direction. So basically my translation t is going to be 1, 0, 0, 0, 1, 0, and 3, 4, 1. So let's recap. You've got a triangle R defined by the points A, B, and C. So there's A, B, and C, and they're just two-dimensional points. And you're asked to rotate the triangle R anti-clockwise by 90 degrees, about 3, 4. So let's recap on what we do. So the first step was we formed a translation matrix. To move 3, 4 to 0, 0, right? And you're going to have to apply this to R and apply to R, the triangle. Then what we're going to do is now we're going to have 3, 4 is going to be at 0, 0, so now we can rotate this new triangle that we got from part 1, rotate this new triangle about 0, 0, right, 0, 0, and then thirdly we will move it back, right? So form the translation matrix to move 0, 0 back to 3, 4, and again apply to the rotated triangle. Okay. So now let me apply each of these 3 steps here, 1, 2, 3, 1, 2, 3, to point A. Right? So point A is that two-dimensional point. Now to apply transformations to it, I have to write it as a 3-dimensional vector, 2, 3, 1. Right? Now I have found the matrices for each of these 3 in the previous part of the video. So the first one was to form the translation matrix to move from 3, 4 to 0, 0. And if you recall, that translation matrix was 1, 0, -3, 0, 1, -4, and 0, 0, 1. So that's part 1 applied to A. For part 2, it says rotate now the new triangle about 0, 0. So I'm going to do that, find the new position of A. So rotate it anti-clockwise by 90 degrees about the origin. So if you recall, the matrix we had for that is this. 1, 0, 0, 0, 0, 1. And then thirdly, form the translation matrix to move 0, 0 to 3, 3 and apply that to A. So if you recall, the translation matrix to do that is 1, 0, moving it from, 0, 0 to 3, 4. So it's going to be add 3, so plus 3, 0, 1, plus 4, and 0, 0, 1. Please recall and note the order in which you do multiplications is important because matrix multiplication is not commutative. You can't, AB is not equal to BA, as it were. So the order in which you do it is very important. So let me emphasize that for you. Firstly, right, you had to translate it 3, 4 to 0, 0. So that has to be applied first to this, right? Then secondly, you do the rotation, so that's why that comes next. And then thirdly, you translate it back, so that's why that one is there. So the order in which you write them down is of vital importance because, as I say, matrix multiplication is not commutative. Now, I have to apply this whole transformation here, which consists of 3 different movements, right, to the point A, right? And I'm going to have to repeat that for B and C also. Now this involves a series of matrix multiplications, as you can see from this. Now the most efficient way of doing this is to form what we call, a combo matrix. Right? A combo matrix, in this case, is going to be a 3 by 3 matrix. A combo matrix is formed by multiplying these 3 matrices that I've highlighted here with the red to form one matrix, and then taking that one combo matrix and applying it to A, B and C. So let's do that. Now I'm going to do it in stages. I'm going to multiply firstly these 2 matrices here together. So I'm going to multiply them here. You're obviously a 3 by 3 multiplied by a 3 by 3. You can multiply them and the answer is going to turn out to be a 3 by 3. To get the first entry, it's in the first row, first column. So you multiply the first row by the first column, the corresponding entries, and add them. 1 by 0 is 0, 0 by 1 is 0, 3 by 0 is 0. Add them all up, you get 0. The next one, you multiply the first row by the second column. So you get 1 by minus 1, which is minus 1, naught and naught, you get minus 1. Then you multiply the first row by the third column. This is the third column here. Here, sure, highlight it. And you go 1 by naught is naught, naught by naught is naught, 3 by 1 is 3, so this value is 3. You repeat that process now for the second row, first column, naught, 1 by 1 is 1, 4 by naught is naught, so it's 1. Naught by minus 1 is naught, and the other 2 are naught as well. Naught by naught, 1 by naught, and 4 by 1 is 4. And then the last row will always be 0, 0, 1. Now, that's the answer to the multiplication of the first 2 matrices. Now what I have to do is multiply it by the third one. 0, 1, 0, minus 3, minus 4, 1. And then at the end, I'll multiply by A, 2, 3, 1. Okay, so I'm going to multiply these 2 together. Obviously, again, it's a 3 by 3 multiplied by a 3 by 3. And what you get is, the first one is 0, 0, 0. So the first value is 0. 0, minus 1, 0. So that's minus 1. Naught, naught, minus 1 by minus 4 is plus 4. 4 plus 3 is 7. 1 is the next value. The next value is naught, naught and naught. And the last value is minus 3, naught and 4. Minus 3 plus 4 is 1. And then the last line is just 0, 0, 1. Let me move the page up a little bit. So now what I'm left with is this one matrix here, right? And this one matrix is, as I said before, is called the combo matrix, right? And basically, it does everything for you. It does the entire rotation of the triangle R about the point 3, 4. So to find my new triangle, I just have to apply this combo matrix to A firstly, and then B and C. So applying it to A, first of all, what I'll discover is A. So 0 by 2 is 0, minus 1 by 3 is minus 3, and plus 7. Minus 3 plus 7 is 4. 1 by 2 is 2, 0 by 3 is 0, 1 by 1 is 1, 2 plus 1 is 3. And then the last value will be 1. So my point 2, 3, that's my A point. When I rotate it by anticlockwise by 90 degrees about the point 3, 4, where I end up with is at 4, 3. So that's my A dash point. So now we apply the combo matrix to points B and C. So let me write that down. The combo matrix is 0, 1, 0, minus 1, 0, 0, 7, 1, 1. And we're going to multiply it by the point B. And the point B is, let me think, 4, 3, 1. Okay, so multiplying them two together. And what we're going to do is 0 by 4 is 0, minus 1 by 3 is minus 3, 7 by 1 is 7, 7 minus 3 is 4, 1 by 4 is 4, 0 and 1, 4 and 1 is 5, so, and that's a 1. So for point B, which is 4, 3, it gets moved to 4, 5. Okay, so that's B, and that's B dash. Okay. If we apply the combo matrix then to C, C, if you recall, was 3, 6, 1. Okay. The combo matrix is 0, 1, 0, minus 1, 0, 0, 7, 1, 1. And if we apply that to this, we will get 0 by 3 is 0, minus 6 plus 7. Minus 6 plus 7 is 1. 3, 0 and 1. 3 and 1 is 4. And there's a 1. So here we have 3, 6 will get mapped onto the point 1, 4. So that's C, and that's C dash. So A dash, B dash, and C dash will form my new triangle. Let's call it R dash. So it's the image of the triangle R that's formed from A, B, and C. Okay, we can show that on the Cartesian plane simply by drawing it. So let me just move this up a little bit and make some room to draw this. So here's the Cartesian plane, and let me plot the first set of points A, B and C to form triangle R. So the first point is 2, 3, and again 2, 3 is just here. I'll draw it in red. Next one is 4, 3. 4, 3 is here. And the next one is 3, 6, so 3, 6 is here. So that's my A, that's my B, and that's my C. And if I join all 3 points, I get my triangle R. So that's triangle R. Now if I change colours and I draw in A dash, B dash, and C dash. So the first one is 4, 3. Now 4, 3 is actually the same point as B. So 4, 3 is actually my A dash, right? So it just turns out to be the same point as B. The next one is 4, 5. 4, 5 is here, right? So that turns out to be my B dash. And the last one is 1, 4. 1, 4 is here, and that's my C dash. So if I join all these, I'll get this triangle here, and that triangle there is R dash. Now if I change colors again, let me put in the point 3, 4 that I did the rotation about. So let me put that in green, right? So there's the point 3, 4. Have I got room? 3, 4, right? Now what did I do? I rotated these points by 90 degrees anti-clockwise. So the whole triangle then went anti-clockwise. There's anti-clockwise, anti-clockwise. Went around by 90 degrees. So you can see, hopefully visually, that's exactly what happened. Now let's look at this question here. You're given a triangle R has vertices 2, 3, 4, 3 and 3, 6, and the triangle R is to be transformed as follows. It says, firstly, rotate R anticlockwise by 90 degrees about 3, 4. Now up to here, that's exactly the same question as the previous question that we've just answered, right? So the firstly was to rotate it anticlockwise, but then we're asked to do another part to our transformation. It says, and then scale by 2 in the x direction and 0.5 in the y direction. So the question asks us to find the matrix C which describes the transformation. So the transformation is consisting of two parts, a rotation about a point and the scaling of the shape. So what I'd like you to do now is to take out a pen and paper and write down all the matrices that are involved in this particular transformation that I'm highlighting here. Right, I'm highlighting here. So write down all the matrices involved and then write them one after the other in the order in which they should occur. Right. Then when you finish that, turn back on the video and I will write them out for you also. Okay, let me write out the matrices that are going to form C. Right, okay. I'm going to start over here on the right hand part of the page because I'm going to apply C to a given set of points, in this case a triangle. Now the first thing I have to do is rotate it, so this is the firstly, rotate R anticlockwise by 90 degrees about 3, 4. Now recall to do that, what did we have to do? We firstly had to write the translation matrix to move 3, 4 to 0, 0. So the translation matrix is 1, 0, and I had to move 3 to 0, so I subtract 3, 0, 1. I had to move 4 to 0, so I subtract 4, and then I have 0, 0, 1. Then what I had to do was I had to rotate or anticlockwise by 90 degrees about, in this case it'll be now the origin, because 3, 4 has gone back to the origin. So the cosine of 90 is 0, the sine of 90 is 1, and it's a minus 0, 1, 0, 0, and 0, 0, 1. Once I've done the rotation then, if you recall, I have to translate it back. So translating it back, I'll have 1, 0, 0, so 0. So I'll go back from 0, 0 to 3, 4. So I add 3 and I add 4, 0, 1. Okay, now them three there are the rotation part of the matrix, right? And this one here is the scaling, because I have to apply that last. So I apply the scaling last, so I scale it by 2 in the x direction and 0.5 in the y direction. Let me recall for you the scaling matrix. I'll just write it up here. The scaling matrix was S, comma T, right, is equal to, so it's S, 0, 0, 0, T, 0, 0, 0, 1. We had that in the last video when I introduced transformations to you. S is the scaling in the x direction, T is the scaling in the y direction. So the value for S for our question is 2, so it's 2, 0, 0, and the value for y in our question is 0.5, so 0.5, 0, and 0, 0, 1. So there's my combination or my combo matrix, which I called C. So this is going to form the combo matrix, right? When I do the multiplications, obviously. So I have to do 3 multiplications to work this out. So what I want you to do now, again, now that you have the matrices written down, I want you to spend a few minutes and work out the multiplication. So firstly, what I'm going to do, right, so you can do it in the same order as me, I'm going to multiply these two together first, then I'm going to take the answer to that and multiply it by that, and then I'm going to take the answer to that and multiply it by that. So I'm going to multiply from left to right. So try that yourself, and when you're finished, turn back on the video and see if we get the same thing. Sorry, I just noticed that value there should be a 1. Okay, let me just move the page up before I start the multiplication. Okay, I'm going to change colors. So I suggested that we're going to multiply these two together first. So I'm going to just write down the answer for you. When we multiply these two matrices, what you're going to get is 2, 0, 6, 0, 0.5, 2, and 0, 0, 1. Okay. Now I still have to, so that's the multiplication of these two matrices will give me this. So I still have to multiply it by these two here. 0 minus 1, 0, 1, 0, 0, 0, 0, 1, and 1, 0, 0, 0, 1, 0, minus 3, minus 4, 1. Okay, so now what I suggested for you to do is multiply these two together. And again, I'm just going to write down the answer for you, and you can double check it if you haven't already done so. So it's 0, 0.5, 0, minus 2, 0, 0, and 6, 2, 1. So that's the answer to that multiplication there. And I still have to multiply it by 1, 0, minus 3, 0, 1, minus 4, 0, 0, 1. Now all I have to do is to perform my final multiplication. So let's write that here. So the solution to the final multiplication is 0, 0.5, 0, minus 2, 0, 0, and 14, 0.5, 1. So that's my combo matrix C, right? Or I could write it aside here. So this is my combo matrix C here. So that combo matrix will do the entire transformation that's defined at the top of that question. I just move up the page here a little bit. You could also have form C by recognizing that you had a good bit of the work done from the previous question, and you could have formed C by having C as being, well, the scaling. Remember the scaling matrix was 2, 0, 0, 0, 0.5, 0, 0, 0, 1. So that was the scaling part of the question. And you could have just multiplied it by the combo matrix that you had got from the previous question. And if you recall what that was, it was 0, 1, 0, minus 1, 0, 0, 7, 1, 1. So that was the combo matrix from the last one that did the rotation about the point 3, 4. Right. So you could just have, saved yourself a bit of work, recognize I have that matrix, multiply these two, and you get exactly the same thing. 0, 0.5, 0, that's a point, minus 2, 0, 0, 14, 0.5, 1. So whichever way you do it, you end up with the same matrix, and that's your combo matrix. So I'll call it the combo matrix. So here's part B of the question then. You're asked to find the coordinates of the triangle R after the transformation. Well, the transformation, or the coordinates for R, the vertices of R, so the vertices for R are A, which was 2, 3, B, which was 4, 3, and C, which was 3, 6. So they're the vertices of the triangle R. Remember our combo matrix, we're just after finding it. So the combo matrix, let me write that down, is 0, 0.5, 0, minus 2, 0, 0, 14, 0.5, 1. Okay. Now what I want you to do is apply the transformation to these 3 points, 3 vertices, and come up with the image of these 3 vertices after the transformation is applied. So again, pause the video and try this yourself for a few minutes, and then come back to me and I'll go through the solution for you. So to find the new coordinates, what we have to do is we have to take the combo matrix and multiply it by each of the individual coordinates. So starting off here, this is at point A, right? Here's the combo matrix, and we're multiplying it by the vector for A, right? So when we do this multiplication, double check it, it's 8, 1.5, 1, right? So this is A dash. So under the transformation, the point 2, 3, which is A, gets moved to 8, 1.5. Okay. You do exactly for the same for B. You rewrite B as a 3-dimensional matrix, as you have here, and multiply it by the combo matrix, and what you'll get is 8, 2.5, 1. So again, what happens is 4, 3, the point B, is moved to 8, 2.5. So maybe I'll write this here. This is A, and this is A dash. This is B, and this is B dash. Doing exactly the same for point C. This is C written as a 3-dimensional vector. Do the multiplication, and what you get is 2, 2, 1. So the point which started off as 3, 6 gets moved to 2, 2 after you apply the transformation. So this is C, and this is C dash. Now let's look at part C of the question. Part C of the question says, draw the triangle before and after the transformation. So again, I'd like you to pause the video and set up a scale for the points A, B and C, and the image points A dash, B dash and C dash, and plot the 2 triangles and see what it looks like. Come back to me then and I'll go through the solution for you. So here's my Cartesian plane with an axis drawn in for X and Y, and I'm going to plot the points R first. So R, the first point is 2, 3, so I'm going to do it in purple, 2, 3. The next point is 4, 3, so 4, 3 is here, and the next point is 3, 6, so 3, 6 is here. We've drawn R before, but that's what it looks like again. Okay, so that's A, that's B, and that's C, and that's triangle R. Now if you plot the image of A, B and C, the first one is 8, 1.5, so 8, 1.5 is this point here, so that's A dash. B dash is 8, 2.5, so 8, 2.5 is here, so that's B dash, right? And then the last point is C dash, which is 2, 2, 2, 2, which is here, so that's C dash. So again, I'll just do the best I can to join them points. Oops. And that's my new triangle R dash. Now you can see it has been rotated, but also it has been rescaled, or has been scaled. It's got shorter along the x-axis, it's halved, so the once it was rotated, and it's got longer along the y-axis, the length of it has doubled.